What do I need in order to be able to subtract fractions? Yes, we need a common denominator, same denominator. Yes. I'm sorry, one more time. Next Wednesday.
You have a question?
Yes.
What's the question?
It's the length of a quiz, but it goes in the test category in the grade book. Will not be open notes. Just the stuff that we're studying this week, yes. We need a common denominator or same denominator. So the first thing I'm going to do when I'm looking at these problems is see if those denominators already have any factors in common. What are factors? Guys, eyes up here, please. What are factors? Things that go into both numbers. So using division, when I say goes into. Factors are anything that if I multiply those pieces together, I get that result. So factors are the parts that I multiply. The product is the result. What are the factors of 4? 2 and 2. Because we're talking about multiplication, you always have to have at least 2 pieces. So 2 and 2 are the factors of 4. What are the factors of 5? 5 and 1. Do they have any factors that are in common?
What?
Do these two denominators have any factors that are in common? No. So if they have no factors in common, then I have to multiply the first fraction by the denominator of the second one. And I have to multiply the second fraction by the denominator of the first one. How do I multiply fractions together again? Straight across, top to top, bottom to bottom. So what will this first fraction become when I multiply it top and bottom by 5? 5 over 20. I'm going to bring down my addition sign. I multiply straight across here, top to top, bottom to bottom. And I get what? 4 over 20. We are subtracting. I just realized I wrote a plus sign instead of a minus. Once I have that common denominator, this is the denominator of my final answer. That common denominator will not change once I have it. And I actually do the operation, I do the subtraction with just the numerators. So 5 minus 4, and I get 1. That is my final answer here. So far, so good? All right. What did we do on the bell work yesterday? We added fractions. What did we need to be able to add fractions? We had a common denominator. So just like with subtracting, we need a common denominator when we are adding fractions together. That's going to hold true when I do this with rational expressions. Go ahead and grab your notes for me. We're going to be on page 7 in your notes. Rational expressions can be added and subtracted only if they have common denominators. Rational expressions can be added and subtracted only if they have common denominators. We want to check for any common factors between the denominators.
Wait, it doesn't say subtract.
Hmm?
It doesn't say subtract.
Where? It doesn't say subtracted on yours? It's true for subtraction too.
I just put subtraction.
That's fine. Check for any common factors between the two denominators. You will multiply by any differences. You're going to multiply by anything that's different. Thank you. And before we look at our first example, I do want to just refresh your memory again. When I say factors, pieces that are multiplied together. They are not factors if they are parts that are being added together. It's only things that are being multiplied together. All right, so example of things that are factors. If I have x plus 1 times x, because those are things that are being multiplied together, each of those are factors. Something like x plus 2, that is not a factor. Why is x plus 2 not showing me factors? There's nothing that's being multiplied there. This whole thing is one factor, and this is a factor, because those are the parts that are being multiplied together. This all by itself, these are not factors by themselves, because they are not being multiplied together.
So if it has parentheses, if it has
All right, so just to clarify a little bit, I can have something that is x plus 2 that is a factor if it's being multiplied to something else. But the x and the 2 on their own are not factors because what's in between them is not multiplication. Does that make sense? Okay. So when I'm asking whether or not these denominators have anything in common, I want to know if they have any pieces that are being multiplied that would be the same. Not pieces that are being added or subtracted that would be the same. You guys ready to look at an example with me? Okay. Let's look at example 6. What are the factors of 4b? What are the things that go into 4b? What multiplies to give you 4b? What multiplies to give you 4? 2 and 2. What's going on between the 4 and the b? Multiplication. So my factors for 4b are 2 and 2 and b. Yes, you were. What are the factors of 10? 5 and 2. These are the factors. I want to know, between these two denominators, if they have any factors in common. Do they have any factors that are the same? They share a 2, right? I need to multiply by whatever is not being shared to get my common denominator. All right, so hold on. I'm going to recopy this. I've got 7a over 4b plus 4c squared over 10. Looking at the first fraction, the first denominator, that 4b, we broke it down to be 2 times 2 times b. 2b is not in common, right? I circled the things that they had in common. They don't have 2b in common, so I have to multiply this second fraction, top and bottom, by the parts that were not in common. I promise there's a method to my madness here. When we start looking at polynomials in the denominator, I want to be able to pick out what they have in common and what they don't. What does the second fraction have that the first one doesn't? 5. So I have to multiply the first fraction, top and bottom, by 5. This fraction already has a 2b in the denominator. This one does not. What happens when I multiply 5 and 4?
20.
I'm going to get 20b right here. What happens when I multiply together here?
20.
I get 20b over here. They had this in common. This fraction had something the second fraction didn't have, so I had to put this over here so that they now had that in common. The second fraction had a 5 that the first one didn't have. So I had to give it to the first fraction so that they would have it in common. Does that make sense? Okay. Multiplying fractions, we multiply straight across. So what am I going to have for my first fraction after I multiply top and bottom by 5? 35a over 20b. I'm going to bring down my addition sign. And I'm going to multiply straight across on my second fraction. What will the second fraction be, top and bottom?
8
C squared b or b c squared. I think on the McGraw-Hill, they want it in alphabetical order. If you're taking a test on paper for me, I don't care about alphabetical order. So 8bc squared over what? Over 20b. So what will be the denominator of my final answer? 20b.
20b is a squared or not squared?
It is not squared. Once you have that common denominator, this is the denominator. Of my answer. So what am I doing the addition with? Yeah, I'm going to add those numerators together. This is the part that we actually do the addition with.
Do you only add the whole numbers and then split all the other numbers to the side?
Are they like terms? No. So it's going to stay 35a plus 8bc squared. These are not like terms, so I can't combine them together anymore. How do I know if something is a like term? What do they have to have that's the same? The variables have to be the same. So they'd have to have all the same variables. In order for these two to be like terms, this one would either have to be 8a or this would have to be 35bc squared. It would have to have all the same letters and they would have to have the same exponents on them. If the letters and the exponents are not identical, they're not like terms and I can't actually combine them together. How are we doing? Okay. I'm wanting to find out before we go look at the next example.
I have a small question.
Yes.
So it feels like 10a over 20b plus 5a b over 20.
I couldn't combine those.
Couldn't combine them.
Nope.
So it would just be like that. But if it was
Yep.
only an a on each side, then you could combine them.
Yes.
But it would still be 1a.
If you had 10a plus 20ab, down here it would be 10a plus 20ab. I can't put them together at all. If it was 10a plus 20a, then I could combine them together into 30a. Only if they have the exact same letters with the exact same exponents on them. Then they're like terms and I can combine them.
So it would be a squared.
It would not be, yeah. It would not be a squared here. What operation makes exponents change? What operation makes exponents change? Multiplication. What are we doing between these fractions? We're adding them. Exponents won't change when I'm adding. Up here they could have changed because I'm multiplying to get a common denominator. When I'm multiplying, exponents can change, but not when I'm adding. Division also, because division is the inverse of multiplication, yes. All right. Do you guys have any other questions for me on this first one? Let's go look at the next example, example 7. And now I want to know who was paying attention when we were doing the bell work and when we got to the first page in your notes today, page 7 up at the top. Do these two denominators have any factors in common? I agree that these two denominators both have x's in them. But what is happening to this x right here? It's squared, it's being multiplied by 3, but it is all together with this addition here. This term is being added to this term. Correct. There's no multiplication there between those two pieces. These are not factors because they are not being multiplied. All right. Can I factor that second denominator? How do I know? How will I know whether or not it's factorable? It has an x squared, so I'm certainly going to try. That doesn't guarantee that it will factor, but it means I need to try. All right. Does it have a GCF? Is there anything that goes into 3 that also goes into 20? Nope. 1. So no GCF. That means I'm going to do my area model and my x. Which pieces do I have up here? This 3x squared, is that A, B, or C? That's A. So that's going to go right here, 3x squared. The 20 is which piece? C. B isn't there, right? What's it equal to if it's not there? 0. So I need to multiply A and C together. So 3 times 20. What is 3 times 20? 60. I need to find two numbers that multiply to 60, but they add to what? 0. 60 times 0 would multiply to 0, but would add to 60. I need it to multiply to 60, but add to 0. There's nothing. If there's nothing that multiplies to A times C and adds to B, that means it does not factor. I tried. It didn't work. Right? So do these denominators have any factors in common? No. Then it's like my Bell work at the beginning where the two denominators didn't have anything in common. I take the first fraction and I multiply it top and bottom by the second denominator. I take the second fraction and multiply it top and bottom by what? By the other denominator. What was the other denominator? Just x. Yep. Yes, you can right back here. How do we multiply fractions together? How do we multiply fractions together? Straight across. In this first piece, what am I actually multiplying here on the top? I'm multiplying the 20 to what? 3x squared plus 20. I'm multiplying it, and I have to use the distributive property. It goes to both pieces. 60x squared plus 400 all over x times 3x squared plus 20. I can write it down just with those two pieces being multiplied. You don't have to distribute on your denominator. You do in the numerator, you don't have to in the denominator. Plus. What happens over here? Multiply by x. So I'm going to multiply these, and we're multiplying these. So what is 200x times x? 200x squared. So I have 200x squared in my numerator over x times 3x squared plus 20. Do I have a common denominator? Yes. So I'm going to add those numerators together. My common denominator is just going to be the denominators of each of these. X times 3x squared plus 20, just written once. I have 60x squared plus 400, yes, plus 200x squared. Do I have any like terms in the numerator?
Yeah.
60x squared and
200x squared.
200x squared. These are like terms.
Add them.
Well, what symbol's between them? Add. So we're going to add those together. What do I get when I add 60x squared with 200x squared? 260x squared plus 400 over x times 3x squared plus 20. I can only combine like terms together. Since the 60 had an x squared with it and the 200 had an x squared with it, I can combine those together. Is that yours? The 3x squared plus 20 because it's being multiplied to the x. I could put that inside parentheses too if I wanted to. It either has to be written with parentheses around the factor or I have to distribute it. But I can't just have x 3x squared plus 20 because that x is being multiplied to the other piece. How we doing? Better? Okay. We got one example to go. Can you hold it like through one more example? Getting that common denominator and then knowing what to do with it. All right. Last example for today. Example 8. You guys okay if I flip to example 8? Does anybody still need this up? All right. Are my denominators the same? No. Do they have any factors that are the same? I don't know yet. What do I have to do in order to determine if they have any factors that are the same? What do I have to do to find out? I have to factor it.
I think you can factor, right? Because
It has A, B, and C, so there's a good chance that this is going to factor. X squared plus 2x plus 1. What's the first thing we always look for when we're factoring?
A, B, and C.
That's the second thing. GCF. No GCF on this. So now I'm going to label A, B, and C. Which piece is A?
X squared.
X squared. Which piece is B?
2x.
2x. Which piece is C?
1.
1. I'm going to draw my area model and my X. All right, so I have X squared here. I have 1 down here. We have to multiply A and C together. What do I get when I multiply A and C together? 1, because I have 1 times 1. I need two numbers that multiply to 1 but add to,
2. You're jumping ahead. It's 2.
adds to our B term, which is 2. What multiplies to 1 but adds to 2? 1 and 1. Because we could find those numbers, this is factorable. So I have 1x and 1x. All right, all my rows and all my columns. What does the top row have in common? What's the GCF? Right here. X. What about the bottom row? What do they have in common? 1. Positive or negative 1? Positive. That is a factor of my denominator. What about my columns? The left column, x squared and 1x. X. And the right column? Positive or negative? Positive. All right, so I can rewrite this first fraction 1 over x plus 1 times x plus 1. Yeah, you could have. All right, so I've recopied my problem, but I factored that denominator. Are these two denominators identical? No. Do they have anything in common? Yeah. X plus 1 is in common with this x plus 1. I can't cancel them. Remember, I'm adding these together. I need the denominators to be identical. What does the first denominator have that the second one doesn't? The parentheses with what? What does this denominator over here have? Another x plus 1. So I have to give this fraction over here another x plus 1. The only way I'm allowed to do that is if I multiply top and bottom by x plus 1. All right, so my first fraction, 1 over x plus 1 times x plus 1 plus, what am I doing right here? I'm multiplying. How do we multiply? Straight across. What am I multiplying x to? X and the 1. So I'm going to have to distribute this x squared plus 1x over x plus 1 times x plus 1. Are those denominators the same now? Yes. So what's the denominator of my answer? X plus 1 squared, or x plus 1 times x plus 1, yes. I don't care which way you write it. We're going to add those numerators together. So I have 1 plus x squared plus x. Are there any like terms there?
No.
Same letters with same exponents? No. So can I actually combine anything? No. Normally, we're going to write our answer in decreasing order, the highest power of x first. In my numerator, what is the highest power of x? X squared. So I have x squared first. Which piece would come second? X. Which piece would come last? Now I'm done.
So it's just like
Yeah, we just changed the order. If you left it like this one right here on the quest next Wednesday, I would accept that. I know that the McGraw-Hill homework gets picky and they want it like this, so they're going to count it wrong. All right, that's the end of the examples for today. What the rest of this class period looks like until D-lunch starts. Are you okay, sir? Yes, you may. Hold on just 1 second, guys. When was homework 1 due? It was due on Tuesday. If you haven't turned that in yet, you need to get it turned in. It was due on Tuesday. What's due today? Homework 2, which is the simplify, multiply, and divide. That one's due today. You guys can use this class period to work on homework 1, homework 2, or the very last homework before spring break is homework 3 that's due on Monday. So one of those 3 assignments I need you guys to work on until the D-lunch bell rings.